Hello, welcome to Excellent Scholars Academy. And today we're going to look at the equivalent resistance of this circuit here. We're going to find the equivalent resistance. In other words, the total resistance of this circuit shown here. All right. So we're asked to find the equivalent resistance across XY of the circuit drawn below. Now, we have, this is XY. Now we have this resistance 1 ohms, 2 ohms, 5 ohms between AB, and we have a 2 ohms here between X and A here. All right, or we have a 2 ohms here, and we have 3 ohms here, 6 ohms here between B and C, and then we have another additional resistor here, 5 ohms. So how do we find the equivalent resistance here? All right, it's very easy. Just follow me carefully. Now, let's label this to be R1. Let's label this to be R2. Let's label this to be R3. Let's label this to be R4. All right. Let's label this to be what? R5. Let's label this to be R6. And then finally R7. All right. Now, watch closely. Now, if you look at this circuit, you will notice that what? R2, R3, and R4 are in parallel. All right? Are in parallel. All right? You will notice that they are what? They are in parallel. Now, how do you find the resistance, all right, of resistors in parallel? And there are 3 resistors in parallel. Now, if there were 2, we would have multiplied them divided by adding them. But there are 3. So how do we do that? Now, and these resistors are between AB, point AB. So let's say 1 over all the resistance between AB, the total resistance between point AB is going to be equal to 1 over, now you say the first one is 1, you say 1 over 1 plus, now 1 over what? 2, the next one, all right, plus what? The next one, 5. That's 1 over what? 5. So 1 over RAB is going to be equal to what? Now, 1 divided by 1, of course, is 1, plus 1 over 2, plus 1 over 5. Now, 1 plus 1 over 2 gives us what? It gives us 3 over 2, all right, plus 1 over 5. Now, the LCM of 2 and 5 is what? 10, all right? So 10 divided by 2 gives us what? 5. 5 times 3 gives us what? 15. Plus 10 divided by 5 gives us 2. 2 times 1 gives us 2, all right? So this is going to be 15 plus 2, that's 17 over 10. So 1 over RAB is equal to what? 17 over 10. Now, to find RAB itself, we inverse this, all right? Just inverse this, all right? So it becomes that RAB is going to be equal to, inverse this side becomes RAB divided by 1, and RAB divided by 1 is RAB. Now, it becomes, inverse this place, it becomes 10 over 17. So we have 10 over 17 ohms, all right? Or if we want it in decimal, 10 divided by 17 is going to give us 0.588. But let's just work with this for now, all right? Let's work with this for now. Or let's put it in decimal. All right. Now, anyone you choose to put it in does not matter. So this is still the same thing as 0.588 ohms. All right. 0.588 ohms. Now, if you also notice, these resistors R5 and R6 between B and C are in parallel also. All right. They are in parallel also, and are the resistors between point B and point C, and they are in parallel, meaning R5 and R6 are in parallel. The 3 ohms resistor and the 6 ohms resistor are in parallel. So how do we do that? And they are in between point B and C. So we can say the resistors between point B and C is going to be equal to. Now, when 2 resistors are connected in parallel, note for 2 resistors, if it's more than 2 resistors, you don't do it for more than 2 resistors, only 2 resistors connected in parallel. It becomes this times this divided by this plus this. So you multiply them, this 3 times 6 divided by adding them. All right. So 3 times 6 gives us what? 18 divided by 3 plus 6 gives us 9. That gives us what? 2 ohms. All right. That gives us 2 ohms. Now, having this, you will now notice that this circuit will reduce to, now we know the resistance between AB, point AB, and we know the total resistance between point BC. Now, the circuit now reduces to this. The circuit will reduce to this. All right. So this is the 2 ohms resistor R1 that was there before. The 2 ohms resistor. Now, this is combining this, all this between point AB, we got what? 0.588. So this is 0.588 ohms. And this is a combination of what? Resistor 2, 3, and what? 4. All right. Now, then combining the resistance between point BC, which were in parallel, that's what? 2 ohms. All right. So we have 2 ohms here, and this was between resistor 5 and 6. All right. And then this last one is 5 ohms resistor, which is R7. All right. R7. Now, what do we do next? Now, if you notice, the 2 ohms resistor and this resistor are in what? Are in series. This resistor, and this resistor are in what? Are in series. So, meaning that we are going to have R1, 2, 3, 4, 5, 6. As a combination of this. That's R1, R2, R3, R4, R5, R6 is going to be equal to what? 2 plus 0.588 plus 2. All right. So this plus this is going to give us what? 4.588 ohms. All right. Now this circuit is going to reduce to this. So this circuit becomes what? It becomes this. So this is 4.588 ohms, and this is 5 ohms. So this is what? R1, 2, 3, 4, 5, 6. And this is what? R7. All right. Now, so this resistor and this resistor are in parallel now. So meaning the total resistance or the equivalent resistance, all right, is going to be what? Like I said, when two resistors are connected in parallel, what do? You multiply them, all right? That's this multiplied by this over, then you add them, 4.588 plus 5. So this is going to be equal to what? So 4.588 multiplied by 5 gives us what? 22.94. 22.94 divided by, now 4.588 plus 5 gives us what? 9.588. 9.588. All right, so let's divide them. So 22.94 divided by 9.588. That gives us 2 point. So our equivalence resistance is going to be equal to what? 2.39 ohms to 2 decimal place. All right? 2.39 ohms. So the total resistance in this circuit drawn here, or the equivalence resistance, is equal to what? 2.39 ohms. So that will be all for that. And that's how to find the equivalent resistance of a circuit like this. Make sure you like this video, share this video, and hit the subscribe button. And also hit the notification bell so that when I upload more videos like this, you get notified. And don't forget, I'm going to drop more videos on how to find the series, the equivalent resistance of a combination of resistors connected in series and in parallel. All right.